Hello again. So today we're doing some harder equations than last time. First of all, we have variables on both sides. Now by the time you see this, you've already done a few variables on both sides equations already. So I'm going to start with a basic one and then go right into a harder one, since you already have a little bit of experience. And we've already combined like terms, so I'm going to assume that you know how to combine like terms as well. So here's our first equation. There are no parentheses, so we don't have to worry about distributing. We can go ahead and start with combining like terms. So on the left side, I see I have two like terms here. And on the right side, I see I have two like terms here and here. And be careful with the negatives here. This is plus negative, so that's plus negative 7x. Or if you prefer, I can write that as 4 minus 7x. And I'd prefer all my x's to be on the left. So to get my x's on the left, I need this to be gone. And I do that by doing APE. And I guess I'll subtract 5 at the same time. And then divide by 17. So to summarize, the first I identify what the common terms are. And then I combine like terms. And then this is the point where I have to get all the variables on one side. So I use APE to do that. If you have variables on both sides, APE will do it. SPE will also do it. MPE or DPE will not do that. It will not accomplish getting variables on one side. Okay, now I'm going to increase the difficulty by putting in some parentheses. Sorry, that's a 2. That's a 2. Okay, so now, since I have parentheses, I have to take care of the parentheses before I combine like terms. Okay, so that I use distributive property to do that. And I'm going to go ahead and add the 10 and the 3. Okay, now there's nothing to do but get my x's on one side. So remember, I use APE or SPE to do that. This is a negative 8x, so I'm going to add 8x to both sides. And now I have a basic two-step equation. SPE. And then DPE. Okay, so you might have noticed that there's sort of a checklist I go through when I solve my equations. So the first thing I check for is parentheses. If I have any parentheses, I get rid of those first because parentheses just make things look really messy. So I use distributive property to get rid of my parentheses. And then after that, I combine like terms, if there's anything to combine. Sometimes there is, sometimes there isn't. And then I clear fractions if there are any fractions. There weren't any in this case, but this is the third thing I look for. And then I get variables on one side. Using APE or SPE. Clearing fractions is MPE. And then after the variables on one side, I should have a simple two-step equation to finish it off. Okay, the last part is going to be devoted to this kind of equation, absolute value equations. So absolute value of x means distance of x from 0. So if this is my real number line, then whatever x is has a certain distance from 0. But if x is a positive number, if the distance of some value is a positive number, it could be over here, but it could be over here too, because distances are always positive. We never say I'm -5 away from something. We just say I'm 5 away from something. And if something is 5 away from 0, it could be over here, or it could be over here. 5 is 5 away from 0, but -5 is also 5 away from 0. So that's what this is saying. I have a mystery number, or numbers, plural, that is 5 away from 0. The number line is showing me that there are two possibilities. X could be 5 or -5. And if you think about it, if this number, whatever this number is here, where 5 is, if that is a positive number, then of course you're going to have two versions. You're going to have two solutions for that number. Some number on the right and the negative version of it on the left. So in this situation, if k is a positive number, you're going to have two solutions. If k is positive, you're going to have two solutions. Now there are two other possibilities. K doesn't have to be positive. It could be 0. If k is 0, it would look like this. So I have a mystery number whose distance away from 0 is 0. Okay, so where would that be on the number line? That would be right here. There's only one number on the number line that is 0 away from 0. It's 0. So in this case, there's only one solution, and that solution is 0. Now the other possibility is absolute value equals k, and k is less than 0. In other words, negative. Well, I said up here that distances are always positive. Distances are never negative. So it would make no sense for me to say that absolute value of x equals a negative number. So in that case, there's no solution. And you can write no solution, or you can just write empty set. Okay, now how do we actually solve equations with absolute value in it? Here's a typical absolute value equation. And you might notice it looks very similar to 2x plus 5 equals 9. The only difference is, instead of x, I have the absolute value of x. Well, when you're solving an absolute value equation, the objective, the destination, is absolute value of x. And then after that, there's one extra step to get x equals. So if this is our destination, I'm really doing no different here than I would here. Here, I'm trying to get x equals. Here, I'm trying to get absolute value of x equals. So I'm going to do the same thing in this equation, this two-step equation, that I would normally do for this equation. So I'll subtract 5. And then I'll divide by 2. Now here's where the extra step comes in. Absolute value of x equals 2. So x is some number that is 2 away from 0. Well, as we set up here, that's two solutions. 2 or negative 2. Here's another example. Okay, in this equation, I have a fraction, and normally we don't like fractions, so I'm going to get rid of that denominator by multiplying everything by 2. Both sides. So this 2 knocks out this 2, and distributing it, 3 times 5 is 15, and on this side, negative 8. And subtracting 15 from both sides, and then dividing by 3. Okay, here you'll see I get absolute value of x equals negative 23 over 3. That's a negative number, so no solution. That is impossible. It's impossible for a number to be negative 23 over 3 away from 0. So my official answer is no solution. Okay, that's absolute value equations, and I'll see you next time.